in some cases, it's not possible to simplify the circuit. So if you look at this example right here, you can see that R2 isn't in parallel with R3, right? Even though they share an end and loosely share an end, there's some batteries in between, so they're not in parallel. R1 and R2 aren't in series, so nothing's in series, nothing's in parallel. Now what do we do? How do we solve this kind of circuit? Well, we essentially apply Kirchhoff's loop rule and junction rule. So we identify the nodes. This points where the circuit branches, so or where we have more than one path in or out. I've identified those by A and B. We draw the current in any direction, split at each junction. So essentially we're going to define a current direction. So we can say there's a current in that branch, we'll call that I1. There's a current in this branch, we'll call that I2. And there's a current in this branch, we'll call I3. And so I don't know what the direction of the current is. I'm just guessing, and I'm just essentially am choosing what is the positive direction of the current. So if I get an answer and at the end the answer is negative, well, that means it just was going opposite of the way I've drawn it. So I'm just going to choose that. And the important point is the number of currents are going to be the number of branches, right? So those are places where the current is the same but can be different. So in this example, there are 3. Next, I'm going to draw the polarities for each element based on my current choices. So for batteries, I know, right, we said before the polarity of the batteries, this long edge of the battery represents the high side of the potential, so that side's always higher than this side on each of those batteries. But for the resistors, we said the current flows from high potential to low potential, so that means this is the high side and this is the low side on R1. This is the high side and this is the low side on R2, and likewise for R3. Okay. Now we're going to use the junction rule at each of the junctions, A and B, and so we can apply that and we can say, hey, what are the sum of the currents in equals the sum of the currents out. So in this case, I1 is coming into junction A and I2 and I3 are going out. So I have I1 is equal to I2 plus I3. I can come to junction B, do the same thing, and I'll find that I2 plus I3 equals I1. So at B, 2 and 3 are entering the junction and 1 is leaving, right? So those two actually say exactly the same thing. We didn't gain any information with that. Next, we're going to use the Kirchhoff's loop rule to go around a loop in any direction, or we're going to go around all 3 of the loops that exist. So the first loop we'll look at is 1 and 2. So that's sort of this loop right here, the blue and the green. So we'll go around the loop. We have the change in potential across battery 1, the change in potential across resistor 1, the change in potential across resistor 2, and the change in potential across the battery 2. And those have to sum to 0. And so we can know the battery, the change in potential is just the EMF of the battery, right? And if we're going around in this clockwise direction, we're going to go from low to high potential, so that's going to be a positive change in potential. When we come to resistor 1, we're going from high potential to low potential, that's going to be a negative change in potential. So if I substitute in Ohm's law, that's going to be minus I1 R1. Across I2 or across R2, we're going to go from high potential to low potential, so that's going to be a negative change in potential, so the drop is going to be minus I2 R2. And then we're going to go across the battery, that's going from a high to a low, so that's going to be minus the EMF of the battery 2 equals 0. We can do the same thing around loop 1 and 3, that's going around this outer side. Or we can go from 2 to 3, we can go around this right side of the equation. So there's 3 different loops that we can choose. Now it turns out we only need 1 junction rule and 2 loop rules, and that sort of is all that we need to solve this equation, but we have 5 choices to choose from. And so now we have 5 equations or essentially 3 different equations and 3 different unknowns, I1, I2, and I3, and so we can just solve those equations and find the currents, and then once we know the currents, we can find the potential differences across all the resistors. Now that really ends this podcast.